Hey, welcome back. This is Mr. Ayers with you. We're lesson 13, adding, subtracting fractions and mixed numbers. Gonna drop some knowledge on you about this stuff. So let's go ahead and get started. Okay, and we got our objective up here is to add and subtract fractions. Okay, and our steps are right here. We need to first write the fractions with common denominators if necessary. That's something that you guys should already know how to do. Step 2 is to add the numerators, and I need to write in here, or subtract, because if it's a subtraction problem, we're obviously going to subtract them. Okay? Step 3 then is to keep the common denominator, and step 4 is to reduce if necessary. Okay? So, here we go. Let's go ahead and do the first one. We're going to do 3/4 plus 3/4. So step 1 is to write the fractions with the common denominator if we need to. But we've already got a common denominator 4, so we can skip that step. Step 2 is to add the numerators. So I'm going to take the numerators, the top numbers. 3 plus 3 is 6. Again, numerator means top number. That should be review. Step 3 says to keep the common denominator. So my common denominator of 4 stays as the denominator when I add fractions. And step 4 says to reduce if necessary. This step is not optional. Okay, you always have to reduce. If I were to leave this answer like this, it would be incorrect. Okay, and I would have to count that wrong. So I'm going to reduce it. Well, I can reduce 6/4. I could divide the top by 2 and the bottom by 2. And get 3/2. Now, this, to Mr. Ayers, is a perfectly acceptable way to leave this answer. 3/2. Okay, that's a great answer because I can't reduce that anymore. Alright, so I'm going to go ahead and just leave it alone. Alright, part B says we're going to take 3/5 minus 3/5. Same thing, I've already got my common denominator, so I can skip that step. So next step is to subtract the numerators. Well, 3 minus 3 is 0. Step 3 says to keep the bottom number the same. And step 4 says to reduce it. Okay? Well, on this one we can't really reduce this, but 0 out of 5, that doesn't make much sense if I look at it this way. So 0 divided by 5, that's always 0. Okay? Anytime the top number is 0, and the answer is 0. Sorry about that. Alright, and let's go ahead and keep on going on to the next slide. Alright, and here we've got some examples without common denominators, so let's talk about those now. Okay? So 2/3 plus 3/4. First thing we need to do is find a least common multiple of 3 and 4. Okay, so we could start a list here of multiples of 3 and multiples of 4 and go till they intersect. Well, 3 we can go 3, 6, 9, 12, 15, and so on. With 4 we can go 4, 8, 12, and here's my match. So my common denominator is 12. So now I need to think to myself, 3 times what gives me 12? Well, I know 3 times 4 gives me 12, so I need to do the same thing to the top. If I multiply the bottom by 4 to get 12, I have to multiply the top by 4 and get 8. Likewise, I know 4 times 3 gives me 12. 4 times 3 is 12, so I need to multiply this top by the same number. And 3 times 3 is 9. Okay? Now I've got common denominators. That's step 1. So now I add the numerators. 8 plus 9 is 17. And keep the denominator the same. Then we need to reduce if we can. Well, there's no number that goes into 17 and 12. Okay, so I cannot reduce that at all. I am done. 17/12. Alright, now let's go B. 3/4 minus 1/6. Same thing, we need to find a common denominator first. So I'm going to go ahead and start a list down here. 4 and 6. If I start my list, I got 4, 8, 12, 16, 20, 24, 28, and so on. If I count by 6's, I go 6, 12. Aha! We already found a match. It's 12 again. Well, I know again 4 times 3 gives me 12, so I have to multiply the top by 3. 3 times 3 is 9. Okay, same thing we had over here. 3/4 is the same as 9/12. This time I know 6 times 2 is 12, so I multiply 1 times 2 and get 2. Now I've got my subtraction problem with my common denominators. So I subtract the tops this time. 9 minus 2 is 7. And I keep the bottom. Then I ask myself, can I reduce this at all? And the answer is no. There's nothing that goes into 7 and 12. So I am done. 7/12. Alright, let's keep on moving along. Objective 2 says that we are going to add and subtract mixed numbers. Okay? So, the only thing that changes about adding and subtracting mixed numbers is the very first step that we have to do is change each of these into just a fraction. Okay? Again, this should be review. So, I need to change 3.5 into a fraction. Well, I do that with the times plus, or the wheel. 2 times 3 is 6, plus 1 is 7. And I keep the bottom number, over 2. Okay, I can do the same thing with 1 3/4. Change it to a fraction. Times plus. 4 times 1 is 4, plus 3 is 7, over 4. Okay, so those are my two numbers I'm going to add now. I am going to add 7/2 plus 7/4. Well, again, now I'm into the adding fractions part. I've got not common denominators, okay? Well, this one's pretty easy to see, that the common denominator is going to be 4. So I don't need to change this number at all. So I'm just going to rewrite that. And I know that 2 times 2 gives me 4. So I have to take 7 times 2, and that's 14. Alright? And then I'm going to go ahead and add these two numbers. Well, 14 plus 7 is 21. Keep the bottom the same, it's 4. And this right here is a perfectly acceptable answer, 21 over 4. Okay, because it cannot be simplified. 4 does not go into 21. 2 is the only other number that goes into 4, and that doesn't go into 21. So I'm done. That's it. Notice how Mr. Ayers likes to keep things in fraction form like this. Okay, reason is that will help us later on. Okay, to realize that we can keep these like this, 21 over 4. Now, I haven't done this yet, but you could change these to mixed numbers. If this really bothers you, you can change it to a mixed number. The way we do that is by taking the top number divided by the bottom number. Okay, and 4 goes into 21 5 times. And then how this works is this right here is my big number. The remainder right here is the top number of the fraction, and then the number outside is the denominator. So it's the same as 5 1/4. Okay? But notice that these denominators are the same. That should always happen. So if you get confused on what goes where, again, big number, and then this number has to be the denominator because it's got to be the same as my fourths that I came up with for a common denominator. Alright, let's move on to example B. Same thing, 3.5. I already changed once by doing times plus. That was 7/2. 1 3/4. Again, just a reminder, I already changed that by doing times plus. 4 times 1 is 4, plus 3 is 7, over 4. Okay, now we're going to subtract these. So I'm taking 7/2 minus 7/4. Alright, and I'm not going to do all the common denominator work again because this is the exact same problem. Okay, I already did 7/2 plus 7/4. Now I'm just subtracting them. So my common denominator problem, I'm just going to rewrite it with the subtraction sign this time. Alright, and so now I just subtract the top numbers. 14 minus 7 equals 7, and my bottom number stays the same, 7/4. Again, if you really want to write that as a mixed number, you could do 7 divided by 4, and 4 goes into 7 one time. I've got 3 leftovers, so it's 1 3/4. Oops, sorry, 1 3/4. So again, we've got, this is our big number. My denominator has to be 4 because that's what it was here, so that means that 3 has to be my top number. 1 3/4. Okay? So on each of these examples, I showed you two different ways to write it. Either one of these is correct, though. They are both perfectly acceptable answers. You need to have one or the other on each one of those. Okay, it's just kind of however you like to write it the best. Mr. Ayers prefers this way because it's less work. Alright, and we got a couple more examples, so let's keep going. Okay, in this problem it says the end of a 2x4 piece of lumber is actually about 1.5 inches by 3.5 inches. If one 2x4 is nailed on top of another, what will be the dimensions of the combined ends? Okay, so basically what they want to know is if I take 1.5 by 3.5 and add on another 1.5 and 3.5, I want to know what are the dimensions going to be. Okay? Well, if I look at this dimension right here, this dimension doesn't change at all. Okay? Because it is stacked on top of each other, it doesn't add anything on to the side. So I know it's going to be something by 3.5. So the only thing that changed is these 1.5s that I have to add together. So I need to take 1.5 plus 1.5. Okay? Well, again, I can change this to a mixed number by times plus, and then 2 times 1 is 2, plus 1 is 3/2. And I'm adding the same number here. So 3 plus 3 is 6. And I keep it over 2. And 6 divided by 2 is 3. So my dimensions are 3 inches by 3.5 inches. Okay? Again, I only had to add the up and down ones. That's the only part that changed. This 3.5 right here did not change at all. Okay? Now let's go on to one last example. Okay, last example says the carpenter cut 15.5 inches from a 2x4 that was 92 5/8 inches long. How long was the resulting 2x4? Okay, so we got this 2x4 here. That's 92 5/8 inches. And we're cutting off 15.5 inches. So basically we want to know how much of this is left over, which means we're going to subtract. So I'm going to take 92 5/8 minus 15.5. Okay? So again, first thing I'm going to do is change this to times plus. You'll notice this one's going to get a little messy here. Okay? So I have to take 92 times 8. Well, 8 times 2 is 16. Carry the 1. 9 times 8 is 72. Plus 1 is 73. Then I need to add 5 yet. So that's 741. So this changes to 741 over 8. Minus, then this one, times plus. 15 times 2 is 30. Plus 1 is 31 over 2. Now I need to find a common denominator on this one. Okay, so a common denominator is going to be 8 here, because 2 times 4 gives me 8. So I need to multiply times 4 and times 4. So my 741 over 8 doesn't change, but 31 times 4 is 124. Okay, 31 times 4, 124. And then 2 times 4 is 8. So now I can subtract those. Okay, so my bottom stays the same, and 741 minus 124, we borrow. Got 11, make that a 3. Got 7, 1, and 6. So 617 over 8 inches. Now, this is a real-world example, so does it make sense to report inches like this, 617 over 8? No, the answer is no. So this is a case where we want to report this as a mixed number. Okay? Real-world example. So let's report that as a mixed number. Remember how we do that. We take the top divided by the bottom. Well, 8 doesn't go into 6, but it goes into 61 7 times, and 7 times 8 is 56. And I subtract, and I get 5 and 7, and 8 goes into 57 7 times, and I got 1 left over, so it's 77 1/8 inches remain. Alright, and that's it on your lesson on adding and subtracting fractions and mixed numbers. Happy homeworking.